Let's imagine something strange, not poetic, not philosophical, but physically precise. Right now, the sun is holding you in place, not just lighting your world, not just warming your skin, but gripping the earth itself in a delicate, invisible dance through space. Now suppose suddenly, without warning, the sun disappears. Not explodes, not fades, just gone. What happens next? Do we freeze instantly? Does Earth fly off into darkness? Or does something even stranger happen, something that seems to break your intuition about how the universe works? Because here's the surprising part. If the sun vanished right now, you wouldn't notice. Not immediately. For about 8 minutes, everything would continue exactly as it is. The sky would still shine, the Earth would still orbit, gravity would still hold. Which raises a disturbing question. If the sun is already gone, how would you know? To understand this, we have to stop thinking of gravity as a force and start thinking of reality itself as something far more subtle and far more unsettling. What happens if the sun suddenly disappears? Let's begin carefully, because when people imagine the sun disappearing, they usually imagine something dramatic, a flash, an explosion, a collapse into darkness. But that's already the first mistake. Physics doesn't care about drama. It cares about information, how it moves, how fast it travels, and what it carries. So let's define the problem precisely. At this exact moment, the sun vanishes. Not explodes, not dims, it simply ceases to exist. Every atom, every photon, every bit of its gravitational influence gone. Now you might expect that the Earth would instantly react, that the sky would go black, that the pull of gravity would release us immediately, and we'd be flung out into space like a stone from a sling. That feels obvious. And it's completely wrong. Nothing happens. Not for a while. The Earth keeps moving exactly as it was moving. The oceans don't shift. The air doesn't stir. The sunlight continues to shine, warm, and scatter across the sky. If you're standing outside, everything looks completely normal. For about 8 minutes, now this is not a trick. It's not an illusion. It's not some delay in perception or limitation of your senses. It's a fundamental feature of how reality is structured. Because nothing in the universe, no signal, no influence, no change travels faster than light. Not even gravity. That's the part that usually surprises people. We tend to think of gravity as something immediate. The sun pulls on the Earth, and the Earth responds instantly. That's the intuition. That's what it feels like should be true. But nature's more careful than that. If something changes, even something as massive as the sun disappearing, that change cannot affect distant objects instantly. The information about that change must travel. And it travels at a very specific speed. The speed of light, about 300,000 kilometers per second. Now the sun is about 150 million kilometers away from Earth. That means it takes sunlight about 8 minutes to reach us. When you look at the sun, you're not seeing it as it is, you're seeing it as it was 8 minutes ago. You're always looking into the past. And the same is true for gravity. The Earth is not responding to where the sun is right now, it's responding to where the sun was 8 minutes ago. The gravitational influence, whatever you want to call, that also propagates at the same speed. So when the sun disappears, the Earth doesn't know it yet. For 8 minutes, the universe continues as if nothing has changed. This is not a delay in reaction. It is the reaction, because in physics, there is no instantaneous. There is only what information has had time to reach you. So for those 8 minutes, you are living in a world where the sun no longer exists, but its influence still does. Now pause there for a moment, because that's already a strange idea. You're being affected by something that isn't there anymore. The light you see is real. It's physically present, traveling through space, but its source is gone. The warmth on your skin is real. The gravitational pull holding the Earth in orbit is real. But the thing causing all of it has already vanished. This tells you something deep about reality. You never experience things as they are. You experience them as they were. Everything you see, not just the sun, is delayed. Even the person sitting across from you is slightly in the past. The further away something is, the further back in time you're seeing it. The universe is not something happening all at once. It's something arriving. Now, after about 8 minutes, something very specific happens. The last photons, the final bits of sunlight, reach the Earth. And then the sky goes dark. Not gradually, not dimming like a sunset. It just stops. One moment the sky is bright, the next the sun is gone. No glow, no fading disk, just blackness where the sun used to be. That alone would be terrifying. But the darkness is only the beginning. At the exact same moment the light disappears, something else happens, something invisible, but far more important. The gravitational influence of the sun disappears too, and now the Earth finally reacts. Up until that moment, the Earth was moving in a curved path, an orbit, because the sun's gravity was constantly pulling it inward. Not like a rope pulling a ball, but more like a continuous bending of motion. Now imagine you're swinging a ball on a string. The ball moves in a circle because the string pulls it inward. But if you cut the string, the ball doesn't fly inward. It flies straight. That's exactly what happens to the Earth. The moment the sun's gravity disappears, the Earth stops orbiting and continues moving in whatever direction it was already going. Not outward, not away from the Sunday, straight ahead. Because motion doesn't need a cause to continue, it only needs a cause to change. And now, there is no cause. So the Earth leaves its orbit silently, smoothly, and begins drifting into deep space. No jolt, no sudden acceleration, just a quiet change in direction. And if you were standing on the surface, you wouldn't feel it, because you were already moving with the Earth. From your perspective, nothing dramatic happens except that the sun has vanished from the sky. Now think about that. You are on a planet that is no longer orbiting anything, moving through space at about 30 kilometers per second in total darkness, and you don't feel a thing. This is one of the strange features of motion. You don't feel constant motion, only changes in motion. As long as the Earth moves smoothly, without sudden forces, you're completely unaware of it. The real consequences come later, much later, because while the disappearance of the sun is immediate in cosmic terms, its effects unfold gradually. The first thing you notice is darkness, but the second thing is temperature. The sun is not just a light source, it's the primary source of energy for the Earth. Almost everything that happens on this planet depends on it. Weather, climate, photosynthesis, ocean currents, all of it is driven by solar energy. Remove that, and the system begins to shut down, but not instantly. The Earth has heat stored in its atmosphere, its oceans, and its surface. That heat doesn't vanish the moment the sun disappears. It begins to leak away. Slowly, over hours, the temperature drops. The sky remains black. Stars become visible in the middle of what used to be day. Within a few days, the average temperature begins to fall significantly. Within a week, it's well below freezing. But again, this is not an explosion, not a collapse. It's a gradual unraveling. The systems that depend on sunlight begin to fail. Photosynthesis stops almost immediately. Plants can't convert light into energy. The base of the food chain is cut off. But life doesn't end right away. Because life, like the Earth itself, has inertia. It keeps going for a while, using stored energy, stored heat, stored resources. The real story of what happens next is not about a sudden catastrophe. It's about how long things last without their primary source of energy. And that turns out to be a very interesting question. Because the Earth is not completely helpless without the Sunday, there are other sources of energy deep underground, in chemical processes, in geothermal heat, tiny compared to the sun, but not zero. So even in complete darkness, some parts of the Earth would continue to function. Not like before, not anything close, but not completely dead either. Now we'll come back to that. But before we go further, it's worth stopping and asking a deeper question. Why does any of this happen the way it does? Why doesn't gravity act instantly? Why is there this delay, this 8-minute window where the Earth continues as if nothing has changed? Because that question leads you to something more fundamental than just the fate of the Earth. It leads you to the structure of space-time itself. Because the reason nothing happens immediately is not just about speed. It's about how reality is connected. And that's where things start to get even stranger. After the sun is gone, the slow collapse of Earth, 8 minutes have passed. The sky has gone black. And for the first time in billions of years, the Earth is alone. No sunrise, no sunset, no direction to the light, just a silent, cold darkness stretching in every direction. At first, it doesn't feel like the end, because the Earth is still warm. The oceans still hold heat. The air still carries energy from the sunlight that was there just minutes ago. The ground beneath your feet still remembers the Sunday. But that memory is fading, slowly, and the universe is very patient. Within the first hour, the temperature begins to drop, not dramatically, not catastrophically, but steadily. You might not even notice it at first. The night feels a little colder than usual, but nothing alarming. After all, nights happen all the time. But this night doesn't end. Hours pass. The stars remain fixed in the sky. No hint of dawn, no change in the horizon, just a constant, unmoving darkness. And that's when the realization begins to settle in. This isn't night. This is permanent. By the end of the first day, the average global temperature begins to fall below freezing in many regions. Not everywhere the oceans are still holding on to heat, but the trend is clear. The Earth is losing energy, and it has no way to replace it. Now here's something important. The Earth doesn't freeze instantly because it's not a thin shell. It's a massive system with layers, atmosphere, oceans, crust, all storing energy. Think of it like a giant battery. The sun charges it constantly. Remove the sun, and the battery begins to drain. But draining takes time. Over the next few days, the temperature continues to fall. The oceans begin to cool. Winds slow down as the temperature differences that drive weather start to disappear. Weather itself begins to die. Storms weaken, clouds thin out. The dynamic, chaotic atmosphere you're used to becomes still. Because weather is powered by sunlight, uneven heating, rising air, pressure differences. Without the sun, the engine stops. The atmosphere doesn't vanish, but it becomes quiet, still, cold. Within a week, the average surface temperature of the Earth drops well below freezing, below 0 Celsius almost everywhere. Rivers begin to freeze. Lakes solidify. The surface of the ocean starts to form a thin layer of ice. But here's something surprising. The oceans don't freeze solid. Not quickly, because water is very good at storing heat. The top layer freezes first, forming an insulating barrier. Beneath that, liquid water remains for a long time. Life, at least in the oceans, doesn't disappear immediately. In fact, some ecosystems might survive for months, even years. But the surface world, the one you and I live in, is changing fast. Plants stop growing almost immediately. Without sunlight, photosynthesis ends. No new energy is being created. The base of the food chain is cut off. Animals don't die instantly, but they begin to run out of food. Ecosystems start collapsing, not in a dramatic explosion, but in a quiet, irreversible decline. Within a few weeks, the Earth is a frozen world. Temperatures drop to negative 40 degrees Celsius, then negative 60 degrees Celsius, then lower. The air becomes sharper, thinner, harder to breathe, not because it's disappearing, but because cold air holds less energy. And then something even more unsettling happens. The sky changes. Without the sun, the sky is no longer blue. The blue color you see during the day comes from sunlight scattering in the atmosphere. Without that light, the sky becomes permanently black even during what used to be daytime. But it's not empty. The stars are there, always. Bright, sharp, unmoving. You would see the universe in a way humans never normally do, a full, uninterrupted view of the cosmos. It would be beautiful and completely terrifying, because that beauty comes with a realization. There is no longer a central star, no anchor, no source of light. The Earth is now just another object drifting through space. Now let's talk about what happens next, not in days or weeks, but in months and years. Because this is where things become truly extreme. After about a year, the average temperature of the Earth drops to around negative 75 degrees Celsius. At this point, the surface is completely frozen. The oceans are covered in thick ice, hundreds of meters deep in some places. But still, beneath that ice, liquid water remains. Because the Earth has another source of heat, internal heat. Radioactive decay inside the planet generates energy. It's small compared to the sun, but it's not zero. This geothermal energy keeps parts of the deep ocean from freezing entirely. And that means something remarkable. Life doesn't completely disappear. Deep sea ecosystems, the ones that rely on hydrothermal vents instead of sunlight, continue to exist. In total darkness, in extreme cold, life finds a way to persist not on the surface, not in the forests or fields, but deep below, in environments that were already independent of the Sunday. But for humans, the story is different. Surface survival becomes nearly impossible. Without sunlight, agriculture fails completely. Food production stops. Within weeks, supply chains collapse. Within months, most accessible food sources are gone. The only way to survive is to go underground, to find heat, to build artificial environments powered by stored energy or geothermal sources. Small pockets of humanity might survive not on the surface, but beneath it, living in controlled environments, isolated from the frozen world above. But even that has limits, because all energy sources eventually run out. Now let's go further. Decades, centuries, what happens to the Earth itself? Without the sun's gravity, the Earth is no longer bound to any orbit. It's moving through space in a straight line, whatever direction it happened to be going at the moment the sun disappeared. That direction is not random. It's the direction of Earth's orbital velocity, about 30 kilometers per second. So the Earth becomes a rogue planet, a wandering world, drifting through the galaxy, unbound to any star. And over long time scales, that has consequences. Because space is not completely empty. There are gravitational influences from other stars, from the galaxy itself. Over millions of years, the Earth's path would be altered, slowly, subtly. But on human time scales, it's just drifting, cold, dark, silent. Now here's a question that might occur to you. Could the Earth ever find another star? Could it be captured by another solar system? In principle, yes, but in practice, it's incredibly unlikely. Space is vast. The distances between stars are enormous. The chance of a rogue planet like Earth passing close enough to another star to be captured is extremely small. So for all practical purposes, the Earth is alone, forever. Now let's step back for a moment, because what we've described so far is not an explosion, not a violent destruction, not a sudden end. It's something else. A slow fading, a gradual loss of energy, a system unwinding itself because its primary source of energy is gone. And that tells you something important. The sun is not just a light in the sky. It's the engine of the entire system. Remove the engine, and everything continues for a while on stored energy. But eventually, everything stops. Not because something destroys it, but because nothing sustains it. And that's a very different kind of ending. Now, in the next part, we'll go even deeper, because what we've described so far assumes something simple, that the sun just disappears. But if you look more carefully at physics, that assumption raises a much more profound question. Is it even possible for something like the sun to just vanish? And if it did, what would that say about the structure of reality itself? That's where things stop being just about planets and temperature, and start becoming something much more unsettling. Can the sun even disappear? And what that breaks in reality? Let's slow down. Because everything we've said so far assumes something very simple. That the sun can just disappear. No explosion, no collapse, no transition into something else. Just gone. But now we have to ask a more uncomfortable question. Is that even allowed? Because physics is not just about what happens. It's about what can happen. And when you look closely, the idea of something like the sun suddenly vanishing completely instantly begins to collide with some of the deepest rules of reality. Not rules we made up. Rules the universe seems to obey without exception. The first problem, conservation. In physics, there's a principle so fundamental that we build everything else on top of it. Nothing is created from nothing. Nothing disappears into nothing. Energy is conserved. Mass is conserved. More precisely, mass and energy are interchangeable, but the total amount doesn't just vanish. Now think about the sunday. It contains about 99.8% of all the mass in the solar system. It is an enormous concentration of energy, nuclear energy, gravitational energy, thermal energy. If the sun suddenly disappears, where did that energy go? You can't just remove that much energy from the universe without consequences. There has to be a trace, a transfer, a transformation, something. But in our thought experiment, we assumed none of that. We assumed a clean disappearance. That's not just unlikely. It's forbidden as far as we know. So already, we're imagining a situation that breaks one of the deepest symmetries of physics. And that's interesting, because when you break a fundamental rule, the universe doesn't just shrug and continue. It reacts. The second problem, space-time isn't empty. We tend to think of space as a stage, an empty background where things happen. Planets move, stars shine, objects exist in space. But that's not quite right. Space itself is part of the system. More precisely, space and time form a single structure, space-time, and that structure is shaped by mass and energy. The sun is not just sitting in space. It is actively shaping it. The Earth's orbit is not caused by an invisible force pulling it inward like a rope. It's caused by the curvature of space-time created by the sun's mass. The Earth is simply following the straightest possible path in a curved geometry. Now imagine removing the sunday You're not just removing an object, you're removing a curvature. You're changing the shape of space-time itself. And that change cannot happen silently. It has to propagate. Just like the information about the sun's disappearance took 8 minutes to reach Earth, the change in space-time geometry also spreads outward. But here's the strange part. That change isn't just a lack of something. It's a disturbance, a ripple, gravitational waves, but something stranger. We know that when massive objects accelerate, like black holes colliding, they produce gravitational waves. Ripples in space-time that travel outward at the speed of light. These waves stretch and compress space as they pass. They've been measured, detected, confirmed. But what about a disappearance? What happens when mass doesn't move, but vanishes? That's not something we've ever observed. But if it were possible, it wouldn't be quiet. It would create a kind of shock in space-time, not like sound, not like light, but a restructuring of geometry itself. Imagine removing the center of a stretched fabric. The fabric doesn't just sit there unchanged. It snaps, adjusts, redistributes. Now, space-time is not a fabric in any literal sense. But the analogy points to something important. Removing mass changes the geometry everywhere, and that change must travel outward. So when the sun disappears, it's not just that gravity turns off. It's that space-time reorganizes itself. And the Earth experiences that reorganization 8 minutes later. That moment when the curvature disappears is the moment the Earth stops orbiting. Not because something pushed it, but because the geometry it was following no longer exists. The third problem, causality. Now we get to something even deeper. Causality. The idea that causes come before effects, that events are ordered in a consistent way. This might seem obvious, but it's actually one of the most delicate structures in physics. Because if information could travel faster than light, causality would break. You could have effects happening before their causes. You could send signals into the past. Reality would become inconsistent. So the universe enforces a strict rule. Nothing travels faster than light. That includes gravity. That includes changes in space-time. So when the sun disappears, the Earth cannot react until the information arrives. That's why there's an 8-minute delay. But now consider this. During those 8 minutes, the Earth is orbiting something that no longer exists. That sounds paradoxical, but it's not, because in physics, what matters is not what exists right now in some absolute sense. What matters is what information has reached you. The Earth is responding to the last known state of space-time, the one encoded in the signals that have already arrived. Reality, in that sense, is local. You don't experience the universe as a whole. You experience the portion of it that has had time to influence you. A strange realization. This leads to a very unsettling idea. At any given moment, you are surrounded by things that may no longer exist. Stars you see in the sky might have already died. Galaxies might have changed. Even the sun in our thought experiment could be gone, and you wouldn't know it yet. You are always living in a slightly outdated version of the universe, not because your senses are slow, but because reality itself is structured that way. So, can the sun disappear? Now we return to the original question. Is it possible? As far as we understand physics today, no, not in the way we described. The sun can change. It can evolve. It can collapse into a white dwarf billions of years from now. But it cannot simply vanish without violating conservation laws, without producing detectable effects, without leaving traces. A true disappearance, clean, instantaneous, leaving nothing behind, is not something our current theories allow, which makes the thought experiment interesting, because it forces you to imagine a universe where the rules are broken. And when you do that, you begin to see just how tightly those rules hold everything together. The deeper point, the real lesson here is not about the Sunday. It's about the structure of reality. The fact that information has a speed limit, geometry can change and propagate, causes and effects are constrained, and nothing simply disappears without consequence. These are not separate facts. They are connected. They form a framework, a kind of invisible architecture that everything in the universe obeys. And when you try to imagine something outside that framework, you don't just get a strange result. You start to see how the framework itself works. Where this leads. So now we've seen 3 layers of the problem. What happens physically after the sun disappears, how the Earth responds over time, why the disappearance itself may not even be possible. But there's one more layer, and it's the strangest one of all, because everything we've discussed so far assumes something you haven't questioned yet, that there is a single shared version of events, that there is one timeline, one sequence of cause and effect. But relativity has already hinted that this might not be entirely true. And in the next part, we're going to push that idea further. We're going to ask, what if different observers don't agree on when the sun disappeared? What if before and after are not absolute? And what that means for something as simple and as terrifying as the sun vanishing. When now breaks, the sun doesn't disappear at the same time. Up to this point, we've been telling the story as if everything happens in a clean sequence. First, the sun disappears. Then 8 minutes later, the Earth reacts. Then the temperature drops. Then the long freeze begins. It sounds simple. It sounds like there's a single timeline, one version of events that everyone agrees on. But that assumption is wrong. And this is where things become deeply unsettling. There is no universal now. We live our lives as if there is a shared present moment, a single now that exists everywhere at the same time. You feel it intuitively. If something happens right now on Earth, you assume it's happening now, everywhere else too, on Mars, on distant stars, across the universe. But physics says that's not how reality works. There is no universal present, no global now. What counts as now depends on how you're moving. Two observers, two realities. Imagine two observers. One is standing on Earth, watching the sky. The other is in a spacecraft, moving away from Earth at a very high speed. Both are looking at the Sunday. Both are trying to answer the same question. When did the sun disappear? You might think they would agree, but they don't. Not exactly. Because when you're moving relative to something, your definition of simultaneous events changes. Events that happen at the same time for one observer do not happen at the same time for another. This is not an illusion, not a measurement error. It's built into the structure of space-time. What this means for the sun. Let's go back to our scenario. The sun disappears. From Earth's perspective, that event happens at a specific moment. Call it time zero. 8 minutes later, the last light arrives and the sky goes dark. That's the Earth's timeline. But for the observer in the spacecraft, moving away from Earth, the timeline is different. From their perspective, the ordering of distant events shifts. The moment the sun disappears and the moment the Earth reacts are not arranged the same way. In fact, depending on their motion, they might calculate that some events on Earth that you consider to be in the past are part of their present, and some things you think haven't happened yet already have. For them, a disturbing possibility. Now think carefully. From your perspective on Earth, the sun disappears 8 minutes later, darkness. Clear, ordered, simple. But from another observer's perspective, that same disappearance might be assigned a different time relative to other events. Not because anything changed physically, but because space-time does not have a single shared slicing into moments. There is no universal clock ticking everywhere at once. The universe as a block. This leads to a very strange picture of reality. Instead of thinking of the universe as something that unfolds moment by moment, think of it as a complete structure, a four-dimensional arrangement of events. Your life is a path through it. The Earth's motion is a path through it. The sun's existence is a region within it, and different observers slice that structure differently. What you call now is just one slice. Another observer, moving differently, cuts through that structure at a different angle, producing a different set of events that they call now. So when did the sun disappear? Here's the uncomfortable answer. There is no single universal answer. The question itself assumes something that doesn't exist, a global moment shared by all observers. Instead, there are many valid answers, each tied to a particular observer's motion. For you on Earth, the sun disappears at one moment. For the fast-moving observer, that same event is located differently in their timeline. Both descriptions are correct. Neither is more real than the other. Let that sink in. We're used to thinking that events have a definite order, that first this happens, then that happens. But in relativity, that ordering is not absolute. For events that are far apart in space, the sequence can depend on your state of motion. So the idea that the sun disappeared and then the Earth reacted is only true in a specific frame of reference. Change the frame, and the story shifts. Does this break reality? It feels like it should. It feels like reality should collapse if people can't agree on what happened first. But it doesn't. because causality, the structure of cause and effect, is still preserved. Events that can influence each other still have a consistent order. Nothing can send information faster than light. So no observer can see the Earth react before the information about the sun's disappearance reaches it. That would break causality. And the universe doesn't allow that. Order without a global timeline. So here's the balance. There is no universal now. There is no single timeline everyone agrees on. But cause and effect are still consistent. This means the universe is more flexible than we expected, but not chaotic. It has structure, just not the structure we intuitively imagine. The deeper consequence. Now go back to the idea of the sun disappearing. You might have thought of it as a single event, one moment when it happens. But now you see something else. That event is part of a larger structure, a point in space-time that different observers relate to differently. There is no single absolute version of. When the sun vanished, there are many valid perspectives, and each one is internally consistent. A shift in perspective. This forces you to rethink something very basic, not just about the Sunday, but about reality itself. The idea that there is a shared present moment is an illusion, a useful one for everyday life, but not fundamental. At the deepest level, reality is not divided into past, present, and future in a universal way. Those divisions depend on the observer, bringing it back. So now we have a much more complete picture. The sun disappears in a way that may not even be physically allowed. The information about that disappearance travels outward at a finite speed. The Earth reacts only when that information arrives. The planet slowly freezes and drifts into deep space. And different observers disagree on how these events are ordered in time. What seemed like a simple question, what happens if the sun suddenly disappears, has led us into something much deeper. A universe where information has a speed limit, geometry can change, time is not universal, and even the ordering of events depends on perspective. What comes next? But there is still one final layer, because everything we've discussed assumes that reality exists in this structured, consistent way with space-time, causality, and observers all fitting together. But there's one question we haven't answered yet, and it's the most unsettling one of all. What does it actually mean to experience any of this? Because physics can describe the motion of planets, the propagation of light, the structure of space-time, but it doesn't tell you what it feels like to be inside that structure. In the final part, we're going to step outside the equations just slightly and ask, if the sun disappears, if the Earth freezes, if time itself depends on perspective, where are you in all of this? Where are you in all of this? Let's step away from the equations for a moment. Not to abandon physics, but to ask what it actually means. Because we've described a world where the sun disappears. The Earth drifts into darkness. Time is not universal. Events don't have a single shared order. And yet, throughout all of this, you are still here, experiencing it. The strange position you're in. Think about what we've just built. A universe where you never see things as they are, only as they were. The present is not universal. The past is not truly gone, just unreachable. And the future is not yet experienced, but still structured by the same laws. You are not standing outside this system. You are inside it. You are part of the same space-time structure that the Earth and the sun belong to, not separate from it, not observing it from a distance, but embedded in it. Right now, you feel like time is passing, like moments are coming into existence, one after another, like the present is moving forward, carrying you with it. But what if that's not what's happening? What if you are the one moving, not through space, but through time, following a path through a structure that already exists? Each moment you experience is not being created. It's being encountered, like walking through a landscape that is already there. Now go back to our scenario. The sun disappears. From one perspective, it's an event. From another, it's just a location in space-time, a point in the structure. The Earth's reaction is another point. The freezing of the planet is another. Your experience standing under the sky, watching the light vanish, is another. All of these exist as part of the same structure, connected, ordered, but not in the simple, linear way you're used to thinking. At first, this feels unsettling because it challenges something very deep, the idea that things truly end, that when something is gone, it is erased. But physics doesn't quite say that. It says something more subtle. That events exist at their coordinates. That what we call the past is not deleted, it's just no longer accessible. The sun shining on the earth right now in this moment exists at a particular location in space-time. If it disappears, that moment doesn't get erased. It remains part of the structure, fixed, unchanging. This is where it's easy to go too far. To turn physics into comfort, to say, nothing is ever truly lost. But physics doesn't quite say that either. It tells you that the structure contains everything that happened. But it does not tell you what it means to experience it. It does not tell you whether those moments are alive in any meaningful sense. It does not promise continuity. It does not promise awareness. It only describes the pattern. And this is the limit, the point where physics stops. It can tell you where events are, how they are connected, how they influence each other. But it cannot tell you what it feels like to be inside those events, why you experience one moment and not another, why you feel like you are moving through time at all. In a universe where the sun can vanish in theory, the earth can drift into darkness, time depends on perspective, and reality is a structured whole. Where are you? You are not outside it. You are not observing it from above. You are a process inside it, a pattern of matter and energy following a path through space-time, experiencing one moment at a time, even if all moments are part of the same structure. Instead of thinking, the sun disappeared and everything ended, think, the universe contains a vast structure of events. Some of those events include the sun shining. Some include the earth frozen in darkness. Some include you right now thinking about all of this. You are not watching the universe unfold. You are part of the unfolding. And maybe the most surprising part is this. The question we started with, what happens if the sun suddenly disappears, is not just about astronomy. It's about how reality works. It forces you to confront the limits of causality, the nature of time, the structure of space-time, and your place within it. What seemed like a simple scenario becomes a window into something much deeper. So imagine it again. The sun is gone. 8 minutes pass. The sky goes black. The earth drifts silently into deep space. Temperatures fall. Life fades. The planet becomes a frozen world. From one perspective, it's a catastrophe. From another, it's just a different region of the same structure, a different set of coordinates, a different part of the universe. You are at one of those coordinates. Right now, experiencing this moment, thinking about a star that might